Hello again. We are going to continue with our sessions. Right now it's going to be the first one of artistic production. We're having two sessions. I'm going to be the chairman of the first one, and my colleague Anahita is going to be the chairman of the second. So for this first session of artistic production, we are having Professor Buket. Professor Buket is an art historian and leader of the DFG-Project Sculptural Machines, a competition of reproductions techniques from 70, which is the topic that he's going to talk about at the Ludwig Maximilians University Munich. Previously, he was a deputy professor at the Department of Historical Image Studies at the Institute of Art History at the University of Regensburg and taught art history at the State Academy of Fine Arts, Stuttgart between 2017 and 2018. She also was an academic assistant at the Institute of Art and Building History, Department of Art History, at the Ulster Institute of Technology. After she completed her doctorate on the topic of Istanbul Academy of Fine Arts with summa cum laude, congratulations, in 2012, under Norbert Schneider in Goslar, published as Die Istanbul Academie von Iron Grünberg bis today. Modern Art National Building and Cultural Transfer in Turkey, Berlin, 2016. She was a fellowship holder in the Mathilde Blanc Teaching Assignment Program at the State Academy of Fine Arts, Stuttgart as well. Between 2007 and 2010, she was a doctoral fellow at the Gutenberg Hochberg Medium and an anthropological perspective at the State Academy for Media and Design in Karlsruhe, supervised by Hans Belting and Peter Weiss. Since 2013, she has been a member of the working group Art Production and Art Theory and Design of Global Migrations of the Ulmer Kunst and Kulturwissenschaften, as well as a member of the research group Research Network for Transcultural Practices in the Art and Humanities of the Humboldt Universität zu Berlin and Reproduct University Heidelberg. So Buket is going to talk about the sculpture machines competition of reproduction techniques 1770 to 1870. Buket, are you here with us? Okay.
So I hope everything's fine with the slides.
Yes.
Can you see? Yeah, great. So then I don't want to waste my time. Thank you for the introduction and many thanks for this kind invitation. Today, I will talk about miniature busts reproduced by Benjamin Cheverton with the help of a machine which he built with his mentor, the engineer John Isaac Hawkins, in the 1820s. Hawkins was, after Sir James Watt in 1809, the first to invent a machine that made it possible to originate copies of sculptures. So-called machines for reproducing sculpture based on a pantograph system, and engineers like Watt and Hawkins developed them in the course of industrialization with mechanical-minded sculptures. Such machines, and in particular the output, were displayed like early photography at different occasions, for instance, the events of the Royal Society and the Great Exhibition, both in London. In this regard, my aim today is to introduce practices and techniques in the context of mechanically reproduced three-dimensional objects of art, and to interpret the sculpture machine as a part of a history or histories of reproduction in order to position them in the intersections of art, science, and technology. With a focus on the agency of the machine and the entanglements, the given example aims to extend the broad understanding of 19th century material culture. Cheverton, on the left, patented his machine for carving reduced size version of sculpture in 1844, which combined then two machines. We see both of these machines invented by James Watt earlier, one for equal size production or reproduction, and one for proportional sculpting. So Cheverton's version was able to copy equally as precisely as its scale could scale down proportionally. His invention was part of the foundation of a commercial industry for machine-made, mostly miniaturized busts. Therefore, I would like to start now by showing a portrait marble bust measuring 66.5 centimeters, made in 1816 by the famous British sculptor Francis Leger Chantry, who was the author of this marble bust and is known for his workshop practice, which, in keeping with the popularity of plaster around 1800, favored the use of plaster models in the production of his sculptures and busts. At the same time, Chantry's character testifies to scientific interest and technology. Earlier in his career, he moved in the circles of Victorian scientific societies, working with engineers and inventors to improve pointing and to some extent sculpting machines, including James Watt, with whom he worked until Watt's death in 1819, and then somewhat later with the engineer and inventor John Isaac Hawkins, and the latter is the mentor of Benjamin Cheverton. From 1800 onward, sculptors were not only experimenting with new materials as a major effect of the first wave of technology during early industrialization, but were also interested in rational production and mechanically respectively automated work processes. In the same time, portraiture is a preferred genre around the turn of the century, as well as in British painting and in sculpture. And not only members of the royal family were portrayed, but as Greg Sullivan pointed out, especially in the Victorian era, many, I quote, politicians as well as aristocrats, engineers, scientists, artists, and writers, end of quote, were depicted according to the antique ideal as a sign for the taste and fashions of the time, like on the slide, the bust of the well-known engineer and inventor James Watt is presenting. Incidentally, the Chantry bust was created precisely for this purpose as a model for Watt in the course of his experiments with the machine in his workshop, as you can see on the right, that aimed at the perfect reproduction of sculptures. In the following, we see the same subject in ivory, but in a smaller version, being reduced more than a half by Benjamin Cheverton, I quote Atterbury, a sculptor in his own right. This miniature bust of James Watt is kept in the Thompson collection of the Ontario Art Gallery in Canada and was produced nearly 3 decades later after Cheverton, and is just under 24 centimeters small. The copy is machine-made, as Cheverton designed the machine based on a 3-dimensional pantograph that we can understand as a collapsible mechanism of levers, capable of reducing or enlarging works of sculpture in scale and in proportion. Not unsimilar to the pointing machine that sculptors like Thorvaldsen or as Chantry did use in their workshops, we have a system of gearing a pointer used to follow the details on the original work, so Cheverton's machine was able to reproduce the same details on a block of plaster or alabaster, but on another scale. That means the sculpture reproducing machine allows further to repeat, resize, or otherwise transfer the proportions of statues into different materials and formats. The process is guided by a pointer touching the original, connected with the pantographic arms to another pointer armed with a cutting tool to carve the copy. Cheverton's machine for reducing to scale portrait busts and statues and figures in 3 dimensions, based like its predecessors on a mechanical arrangement with 2 arms, the pantograph. While one arm is scanning the original, the other, equipped with a rotating cutting device, removed material from a block. The given illustration shows feeler and cutter, which sit on a rod at a distance from each other, and calculate the desired reduction bar, since a cardan joint allows the feeler and cutter to be brought into any position of need. In the editorial to the 2013 issue of History of Photography, Patricia Di Bello informed us about the accurateness of this process. I quote her, "In Watts and Cheverton's machines, original and copy are clamped to plates connected by geared arrangements that keep them in the correct spatial relationship as they rotate to carve new portions of the copy, layer by layer. This enables the manufacture of exact copies in different sizes, but in the right proportion, which is impossible with molding and casting alone," end of quote. This aspect of the reliability of the copy we can observe in the presentation of the Thompson collection on the left, as the displayed model of the machine is referring to the protagonists Watt, Chantry, and Cheverton, who were all involved in the development of this technique of reproduction. Therefore, this is, you see this tiny model showing Cheverton's sculpture machine on the left, as explained. As a result of this chain of replication, to speak with Malcolm Baker, there are several versions of the same depiction in different size formats produced with the sculpture reproducing machine, like this London version of the bust measuring 28.6 centimeters. So same, but different. Besides ivory, that due to its material nature was a common concept for marble, we see this miniaturized portrait with a smoothly polished surface bearing witness to a different use and mix of materials. According to the curators of the London Science Museum, we are dealing with an object made of plaster and plastic coating, mounted on an Italian marble column having one glass cover, with it attached to a plinth of dark brass, which is positioned on a round wooden pedestal. Another material imitating marble in a mass reproducible form is statuary porcelain or Parian. As a variant of biscuit porcelain, Parian was developed by the English firm Copeland and Garrett between 1842 and 45, as an imitation, as you all know, of the famous Sèvres biscuit. According to its material qualities and resemblances, Paul Atterbury sees Parian quite extensively used throughout the 19th century for the manufacture of domestic and other wares such as stoneware and drab. In 1846, the firm Wedgwood chose the name Carrara for their version of new Parian material because of its close resemblance to the marble from the quarries around Carrara, renowned for its exquisite color, its texture, and its grain, as Maureen Betkin is explaining. The most important feature of a Parian reproduction of a work by a contemporary artist was, according to Atterbury, I quote, "its accuracy in both proportion and detail, despite being greatly reduced," end of the quote. This fired but unglazed porcelain was introduced shortly after others supplied new and affordable materials for copying sculpture. Overlapping with the machine processes that were to become common in sculpture workshops, chemical developments offered new and more affordable materials for reproducing sculpture, like, for example, galvanoplastic and electrotyping, which we heard yesterday of. They had emerged in around 1838, just a few years before Parian ware, also as a new, more economical and reliable method of casting sculptures, especially as plating base metals in bronze or silver, like this example of this reproduced Venus de Milo is showing, and which is executed by the French variant of the machine invented by Achille Collat in 1838. Both Collat, who was in commission for the French firm Barbedienne, and his counterpart in Britain, Cheverton, worked with manufacturers, the latter with the Minton's Pottery and the firm Elkington & Co. to produce hundreds of copies in plaster Parian ware or in electro bronze, but also ivory imported from West Africa and Bombay. It is interesting also, according to Gabriel Williams' dissertation, that these chemical developments emerging all approximately the same time and intersecting with the mechanical technologies that were used by mechanical-minded sculptors in cooperation with manufacturers. Further, in her essay, Photographs of Sculpture, De Bello draws attention to the connection between, I quote, the boom of statuary porcelain, end of quote, and the use of the sculpture reducing machine as well as its success at the World's Fair. Due to its design, Cheverton not only created much more precise copies, but was also the first to exploit the sculpture machine commercially after having great success at the Great Exhibition in London. Cheverton was very busy in the decades following the Great Exhibition because of the growing demand for reductions of artworks in different materials, also fostered by institutions like the Art Union and the Arundel Society. Cheverton's success was granted for copying to scale, I quote, plaster versions of the marble sculptures, end of quote, as well as originals by famous sculptors like Sir Francis Chantry. Sorry, I have to drink a bit water. I'm sorry. So I hope now it's better. Yes, like Chantry. Cheverton demonstrated his machine at the Great Exhibition in 1851. According to the jury reports, he also displayed his statuettes, busts, and bas-reliefs in ivory, alabaster, marble, and metal. The jury highlighted that more importantly than the materials, which are new, Cheverton carved them, I quote, by a machine from originals of a larger size, end of the quote. The additional comment that, I quote again, those in ivory and marble are not finished by hand, end of quote, underlines that under the sign of mechanical innovation and technical application of materials, the presentation of automation via machine as an experiment generated popularity and was intended to serve the magical entertainment of the scientific as well as the public audience. Speaking on the occasion of the opening of an exhibition by the Arundel Society at the Crystal Palace in 1855, the architect Matthew Digby White described Cheverton's reductions of Theseus, Ilius, and the Slab 47 of the Parthenon frieze as, I quote, reproduced microscopically, almost magically, end of quote. The Daily News also noted, I quote, the truthfulness with which the dilapidated condition of the latter is depicted, end of quote, and the utility of the reproduction for those who had not studied the marble original in the British Museum, where it's located. Such references to this reliability and almost impossible precision of the objects produced through the machine remaking after Rebecca Wade, I quote, machine obscure multiple processes of reproduction and material translation. For the alabaster copy of Theseus, Cheverton achieved the prize medal from the jury of the Great Exhibition, I quote, as exemplifying the reduction by machinery of statues, end of quote. A further copy of the same figure is mentioned in the catalogue as produced, I quote, for the Arundel Society in Electro Bronze, end of quote, who made it their goal to promote a greater knowledge of art through reproductions. Given the fact that we could compare this technique with early photography, it is worth especially considering the notion without the use of human hand to look more in detail at a photograph on the right, most probably taken in 1920s, showing Cheverton's machine in operation. Although it remains to be clarified whether there are other historically older pictures that could be used for comparison to analyze the depiction presenting an archaic-looking wooden construction with an integrated three-dimensional pantograph, it is most remarkable that this original, a plaster cast, landed from the British Museum, and a small blank, both mounted vertically. Apart from some tools and the bust placed on the floor, there is nothing else. To the contrary, the scene on the background is empty. In this respect, the staging seems magic because Cheverton's machine pretends to carry out the reproduction process as by itself without the help of the sculpture. However, the sculpture himself is present in the form of the self-portrait, as the bust placed on the floor turns out on closer inspection, testifying to the mental presence of the inventor of the machine. Due to this classical artist's topos, it is probably no coincidence that the plaster bust I was talking about, and which was mounted here for reproduction, is no less than another version of that of William Henry Fox Talbot, fancifully titled Patroclus.
Professor, please, I would like to ask you to conclude.
Oh, I'm coming to the end. According to Geoffrey Batchen, who analyzes this well-known plaster bust in the context of Talbot's early photographic experiments, the ancient heroic tale of self-sacrifice must have been all too familiar to the contemporary audience who knew Homer's Iliad. In the battle for Troy against Hector, Patroclus, who faithfully replaced his companion Achilles, fell tragically. This specific form of rhetorical substitution is, according to Batchen, exhausted in an endless string of medial substitutions. I quote, "The plaster bust stands in for a human figure, a photograph of for the plaster bust, and the bust for the original marble carving," and yes, and so on. Whoever may have staged this scene must inevitably have drawn a connection to the first photographic attempts. Talbot published in 1844, the same year as Cheverton achieved the patent for his machine, the first photo book in history and manifesto, The Pencil of Nature, which shows the identical plaster busts, plates 4 and 17, depicting Patroclus in different experimental views. 1 year later, in 1845, the Royal Society exhibited some of his mechanically made copies in ivory, such as the bust of Queen Victoria, which Cheverton made after the original by Sir Francis Legend Chantrey. This exhibition was not only prominently well attended with the Marquis of Northampton and Prince Albert, as we can read, but also presented a number of works of art and manufactures set out on the tables to be admired by men of every rank and profession in the higher walks of life, end of quote. So one can assume that Talbot and Cheverton knew each other, especially as they must have met during kinds of society events and presented their works results for to compare. So I skip this quote. So interfaces and overlaps are striking. I think it is no coincidence that the plaster bust of Patroclus, borrowed from the British Museum, has been a popular motif both in the photographs made by Talbot and, as it could be assumed, in the use of Cheverton's sculpture machine in the current Cheverton collection at the Art Gallery of Ontario in Toronto, which comprises several hundred miniature ivory busts. There is the similar reduced one with a smooth surface entitled Patroclus and dates from early 1840. Thank you for your attention.